Okay, AP Physics, review with a multiple choice. One is D, angular momentum and linear momentum. Particle comes in, hits, that generates one force, or a change in momentum. It bounces off, that generates a second force. Remember, Newton said a force is really a change in momentum over time. So you get two forces. Torque is really RF sine theta. They're both at 90, so that's out. F here is actually 2. It's P1 and PF, and R is actually D. And that would lead you to the answer D. Both the momentums, which are two forces, times the distance, or radius arm here. 2. 1. Sound wave can't travel faster. It's in the same medium, same speed. That's out. Again, same medium, same speed. B's out. C seems probable. The greater displacement means the greater compression, displacement, compression, leading to a louder sound. The opposite of that would be D. So C is the answer there. Number 3, the one people love to hate. Really kind of nasty. There's a lot of velocity here, but in physics, things keep doing what they're doing unless they're acted on by an outside force. That's Newton's first law. So the center of mass is going to keep doing what it's doing unless there's an outside force, which is D. There is internal forces. The thing explodes, but those are the third law, and they affect both of these the same, so they don't change the overall system. So even though when it blows apart, this gets a force in the direction of its momentum, gains some speed. The pod gets a force in the opposite direction, loses some speed. The center of mass may be in the place where there's no mass, but nothing has affected it, so it's D. 4, two strings differing only in length. We've done this. Everything's the same. They have the same tension, the same linear density, so the speed has to be the same. Oscillator frequency in a standing wave on one length cannot result in a standing wave on a string with a different length. Of course it does. There's the formula for a string, wave on a string, and an open tube. Amplitude's not terribly important for standing wave as long as you have a minimum amplitude to sort of generate the standing wave. So that's out. D. D is the correct answer. The wavelength is not enough to give it a standing wave. For D. Now if we look at the last two, multiple choice. Okay, number 5 should be easy money. You do the resistance and the current total with this parallel branch, and that, remember, it's 1 over 100 plus 1 over 100 plus the series, 150, Ohm's law, you get that current. Voltage drop against this is its total current times its resistance, 1 volt, or 2 volts rather, that means this is 1 volt. You remove this, it becomes a series, 200 ohms here, 200 ohms. And then since they're now both 100, they both share a voltage drop of 1.5. So you compare 1 volt to 1.5, the answer is C. 6, easy money. Gravity has to have a constant slope. The slope of a v versus t is acceleration. So this B is the only one because the slope is constant and the same.